This Java code defines a charging station class. The charging station class is serializable. An instance of logger logs the event of the class. These variables represent the location of the charging station, its availability status, maximum capacity, and current available slots. Here we have the occupy method that is synchronized, ensuring that only one thread can access it at a time. It allows a car to occupy the charging station. If there are available slots, if successful, it decreases the available slots, sets the station as unavailable, and logs the event. If no slots are available, it logs that the station is full for the specific car. The release method here is synchronized, allowing only one thread to release the station at a time. It marks the charging station as available and increments the current available slots. The method at the end logs the event of the releasing station. This code simulates a scenario where multiple cars try to charge that charging station with limited capacity. It has three different phases: initialization phase and simulation loop and the logging event. In the initialization loop, two charging stations are created and added to the list, and they have unique location and maximum capacity of available slots for cars. The three cars are initialized, each with a name and a maximum waiting time. The maximum wait time represents the time a car is willing to wait for a charging slot. A log message here generated to indicate the completion of the initialization process. Here in the simulation loop, it iterates through each car and attempts to find an available charging station. If a station is available, the car occupies it. Otherwise, a message is logged indicating that no slots are available. At the end, a log message is generated to indicate that the completion of the simulation.
So I am presenting the charging station class here. So this is the necessary libraries that we are using, and then we have taken charging station class that will implement the serializable. That means the object of this class will be serialized. So here we have initiated two type of variables. The logger will log the messages, and this is the maximum waiting time for each car. And here we have taken some variables, that is max capacity is the maximum charging station and then of the station, and then this current capacity is the current available charging slots in the station. This is the constructor, and we have made the availability is true at first, and then here in the occupy method we are checking that the current capacity is more than 0 or not. If it is, then it will be increased, the availability will be false. And then in this release method we are checking that this availability is true or not. If it is true, then the current capacity will be increased, and in the logger that will show a message. In this method is available method, we are checking that if there are unavailable slots for charging there or not. And then this get location method will return the location. And then this synchronized add to queue method will calculate the waiting time here for 5 seconds per car in the queue, and it will return the waiting time. And then this simulate arrival car is this car is added to the queue, and it is checking that waiting time is more than maximum waiting time or not, I mean 15 minutes or not. And if it is, then it will show a message in the logger, or if it is not, then it will simulate the charging time, and then it will be removed from the queue, and it will show a message that finished charging and then left the station.
Hello, my name is Daniela, and I'll be talking about the charging station simulation class. Basically, this class is responsible for the simulation of 5 cars coming into the charging station. In this class, we have a logger that basically logs the events from the starting of the simulation to the end of the simulation. At the beginning of the simulation, we have a string saying starting car charging simulation. It has a maximum wait time of 15 minutes. We have 2 charging stations with different charging capacities. We have a scheduled executor service which is responsible for the simulation of the two charging stations. The car arrive in random delays up to 10 seconds, and then they are assigned to random charging stations. The whole simulation occurs in 1 minute, and when it's done, we also have another log system event that tells us simulation complete, exiting program. So basically, that is how it works. When we run it here, we can see that on it gives us a date, a time, and then a car. It gives us a starting of the stimulation, and then the cars are assigned to random, what's the name? Random charging stations with their delay and their wait times. And at the end of the simulation, we have another output which says simulation complete, exiting program. So basically, this is what this class is responsible for. Thank you very much.
Hello, my name is Samuel. I'm in Team 12. We have to simulate multi-thread charging. I worked on simulating multi-thread charging of the reserve batteries from several energy sources. So the first thing we did is to create a class of reserve battery, which has an ID and is fully charged variable. This variable is to say when a battery is fully charged, we set it as true. Basically, it's a Boolean. And so there's a method also to mark as fully charged or is fully charged to get that. We also have the different energy sources, which are an enum of solar, wind, and grid. This we can use to charge different batteries that we have. And also in the charging station, we added a charge battery method to simulate charging a battery in a thread-safe way. So we have this lock and unlock method, call method called on the lock instance of the lock from the concurrent class, basically. So the charge battery accepts the battery and the energy source as a parameters. And basically what we are doing is when this method is called, we lock this thread and we sleep. We use the thread or sleep, which is basically to pause for 3 seconds. And then we mark the battery as fully charged. Basically, we are saying here that it takes 3 seconds to fully charge the battery, just as a demo, basically. And also, this method is called from the charging simulation class. Basically, what we have here is the charging station. Two instances of the charging station, station A and B. And we have an executor service. We created a constance of 5 batteries, and we are looping through each of the battery. Or then we create an instance of each of the battery. We get a random energy source from the enum list of values that we have. We also get the charging station. We alternate between the charge stations we have. At least one charge station will be used minimum of twice, the other one 3 times. And we are basically executing this, we are calling executor service here to submit this method into the thread. And so when this station.charge battery method is called, we charge the battery in a thread safe way for 3 seconds, and we log battery fully charged or charged successfully. Yes, that's all for that simulation. Thank you.
Yay.